Alright guys, so for today's video, we're going to be continuing our discussion on Ohm's Law, this time using a new analogy that I've been cooking up. So, you see, charges flowing in a circuit are really just like carries in MOBAs. Stay with me now. You see, for those who don't know, a carry is typically the character with the most potential in the team. That is because by the end of the game, they're expected to have the most kills, the most KDA. When it comes to buying items, they usually have the highest priority. They're supposed to have the most amount of gold in the team. And at the start of the game, carries are the characters that have the most potential. And later on, they lose this potential because they're already using it, they're already achieving it. And what I mean by that is, 5 minutes into the game, your ADC might have got 1 kill already, 3 assists, a little bit of 500 damage. Like, they've already used a little bit of their potential because they're doing a little bit of what they're supposed to do. But really, there's still a lot more potential for them to unlock. Which is why, at the end of the game, they're already unlocked their full potential. This is the most that they can do. They could have got their pentakill, or the monster kill, something like that. Or their total damage just skyrockets, stuff like that. And so you could say that as the game progresses, they lose their potential because they're already trying to achieve it, They have to use their potential and completely empty it out so they can achieve it, they can unlock their potential. And the same can be said for charges in a circuit. You see, charges also start with the most amount of potential. They start at the battery where they have the highest amount of electric potential. And the way they unlock their potential is by moving along the circuit. Over the course of time and the circuit, the charges slowly lose potential because they're already using their potential in order to move forward in the circuit. So, if a carry uses potential to kill people and get more money and stuff, then for charges, they use their potential in order to move along the circuit. This is why electrons or charges, as they move along an electric field or an electric circuit, this is why they lose potential. And we've actually already seen examples of this. Do you remember those sample problems we had where you had two electric plates, one positive and negative? Did you ever wonder why, when we find the potential of the charge at these 2 points, did you ever start to wonder, why is it that, at point A, it's got so much higher potential than at point B? Well, that's because it has to use the potential it had in order to move to point B. So, from point A to point B, it had to use that remaining potential it had in order to reach to point B. Because, like I said, the way that charges use their potential is quite literally just moving along the field or the circuit. And I like this analogy a lot more than the water pipes analogy because it lets people understand that voltage doesn't actually just exist in the battery. You see, if you only stuck with the water pipe analogy, you might start to think that because the gush of water is only at the start, then surely voltage must only be at the battery too. But this isn't true because, as we've seen, the charges themselves have the potential. The charges are carrying the potential and they're using it throughout the circuit. So, I hope that helps you understand voltage and electric charges in a nutshell. And let's move on to the next video.